So today, instead of talking really consecutively about the atom, we're gonna drop it a little. But remember those; those are very important in later discussions. Today, we're gonna talk about maybe a little bit about the history of quantum mechanics. So, first, quantum mechanics. Everyone knows developed by Niels Bohr, Werner Heisenberg, Paul Dirac, Wolfgang Pauli, and all those people. But in fact, they developed a new quantum theory known as quantum mechanics. But there's the old quantum theory. Before the theory, the quantum theory and Bohr's model was made, probably in the time where Rutherford made his theory about the planetary model, there's another mystery. It's called the black body model. Black body. When we talk about black body, we're not talking about black holes. That's like everything. It's just black is some completely different. It's completely different. So it was it's really puzzling everyone. Nobody could solve it. And at the time, people thought physics was dead because everyone figured it out. Obviously, they didn't know the subatomic worlds. This is one of the key aspects that led to quantum mechanics. There were some key aspects that led to quantum mechanics. So, there's a guy called Max Planck. He's from Germany, and he's really smart, like the Albert Einstein kind of freakishly smart. So, when he go to college, he said he wants to study physics. So what do you want to solve? This. So, to solve this, Planck did various amount of calculations, and he had an idea. What if there are little energy packets called quantum? So he thought, yeah, this may be useful, and he did some more calculation, and found a shocking result that he found the world is non-connective. So that means it is non-linear radical. That means like so time is linear radical. I'm talking about here, I'm talking about that. I'm talking about this, I'm talking about 1, then I'll move to 2. There's a cost, there's a very smooth change, but non-linear radical, it means it's a big jump. It's not like a line. It's bumpy, it's broken down, it's a line, 1,000 lines, 1,000 lines not even connected. That is non-linear radical. And in that times is really shocking, and still very shocking now. It's just doesn't make sense at all. So he proposed this theory, So he called quantums, or quanta, if we're talking about plural. That's where the concept of quantum came from. But he thinks this is too shocking. He threw it away. And then Albert Einstein came. He proposed that quantum actually exists. This is photon. A photon is an electromagnetic wave that before people thought it was just a wave without the little particle in front. Instead, Einstein proposed that this is a quantum. Photons are quantas. So this is a photon. It is both wave and a particle. That's called a wave-particle duality. It is first proposed by Albert Einstein. Then it is then developed by Broglie, a French scientist, which said all things have wave-particle duality. Most people think this is just absolute nonsense. How could one thing is wave and one thing is a particle at both? But then some scientists doing some like experiments and proved that actually electrons also behave like waves. So wave-particle duality is proved. That means the world is actually non-linear radical. People don't know what the hell is going on. So what they didn't know is that it was actually part of the subatomic world. Subatomic world. So that's what happens when you put Newtonian physics into the subatomic world. That's why we're now breaking apart right now. So people are just freaked out. Then quantum mechanics came along. We're going to talk in later episodes. That's basically called the old quantum theory. Thank you.